Okay, so our learning goal today, the new part today, is I can use the divisibility rules. And these are actually rules that you should have been exposed to already. Let's see if you remember any of them. So in other words, how can you tell if a number is divisible by 2, 3, 4, 5, 6, 9, and 10? How can you look at that number and take it kind of like a shortcut and say, I should be able to divide this by this particular integer, okay? So anybody know the divisibility rule for being able to divide a number by 2? What's the divisibility rule for dividing by 2? Right? Yeah, basically it has to be an even number, but that's not really the rule. All even numbers are divisible by 2, but the divisibility rule states it a little bit differently. It says, so I have the if here already, so let's just circle the word if. Okay, we're not going to write if every time. So a number is divisible by 2 if the last digit is divisible by 2. So it's a lot easier to just look at one digit and say, can I take 2 into that number? So whatever the number is, it can be a 6-digit number like 132,788. And all you'd have to look at is that final digit of 8 and say, can I take 2 into 8? And if I can, then I know that the whole number is divisible by 2. Okay? How about the divisibility rule for 3? Anybody know that one? Okay. So this one is, if you add up all the digits, so we're going to say the sum of the digits is divisible by 3. Okay, so get that written out. So you know that a number can be divided by 3 if, when you add up all the digits, you can take 3 into that number. So an example, 132 is divisible by 3 because the digits 1 plus 3 plus 2. What's 1 plus 3? 4 plus 2 more is 6. Is 6 divisible by 3? Yes, then that means 132 is divisible by 3. Okay? Anybody know the divisibility rule for 4? I'm going to guess if you don't know the more common one, like 3. 4 is the one of the trickier ones. Anybody got it? Okay. A number is divisible by 4 if the last 2 digits are divisible by 4. So this one you have to think a little bit harder on because you have to know the multiplication table for 4. You need to know the multiples of 4. So you're going to look at the last 2 digits of any number, and if you can divide those 2 digits by 4, you know the number is divisible by 4. Okay? 5. Anybody know the divisibility rule for 5? I bet you know this one. What's the divisibility rule for 5? How do you look at a number and know that it is divisible by 5? I know you know this one. Sylvia? If the last number is divisible by 5, we can even narrow it down more than that. If the last digit is, just when I thought you were going to be able to show off your geniuses, the last digit is 0 or 5. Does that sound familiar? If the last digit is 0 or 5, you know that number is divisible divisible by 5. Okay. 6, this one's probably one of the hardest ones. This is the one that, you know, even remembering the divisibility rule for is kind of hard. And then you have to work harder at this one because it has to have, if a number is divisible by 6, if the number is divisible by 2 and 3. You can divide a number by 6 if that number is divisible by 2 and 3. So here's the deal. For this one, you got to remember 3 divisibility rules. You got to remember the divisibility rule for 6, first of all. And then, since it has to be divisible by both 2 and 3, you got to remember both of those divisibility rules also. So this is probably the trickiest, hardest one that sometimes you're like, you know, it'd be just a lot easier to just try and divide 6 into it and to run it through the rule. Okay, 9, the divisibility rule for 9. Anybody know that one? It's kind of like the rule, divisibility rule for 3. And not exactly like it, but it's a whole lot like it. You didn't learn this trick in grade school, huh? If you, go ahead, Wade.
The sum of the numbers is equal to 9.
Not equal to 9, but divisible by 9. Yeah, the sum of the digits is divisible by 9. Sum of the digits is divisible by 9. So you add up all the digits and see if you can divide them by 9. Yes, wait. You know the next one? Okay, what's the rule for dividing by 10?
The last digit is 0.
Yep, if the last digit is 0. So the last digit is 0. If the number ends in a 0, it's divisible by 10, right? Okay. So, let's practice some of these. See if we can do some of them. Is 72 divisible by 3? So what would we have to, what test do we need to run this one through? Do we want to know if it can be divided by 3? What do we have to do? What does the rule say? What does the rule say?
So it's a digit.
Sum of the digits. We got to add 7 and 2 together. 7 plus 2, what does that equal? What does it equal? 9. And then we say, can I divide 9 by 3 and get an integer, no remainder? Is 9 divisible by 3? Yes, it is. So we get 3 when we do that. That does not mean, okay, this is the fear I have of us mixing up divisibility rules and the answer to division problems. This does not mean that the answer to 72 divided by 3 is 3. That is not what we've just found. Nor is it 9. We just found what? What was the question? Is 72 divisible by 3? So what are we going to say?
Yeah.
Yes, but we don't know right now what it is, do we? We just know that if somebody said to you, is 72 divisible by 3, you go, okay, let's see, 7 plus 2 is 9. And 9 divided by 3 is 3. You go, yes! That's all you have to do. That's all they asked you, didn't they? Is 72 divisible by 3? Anybody happen to know what the quotient is for 72 divided by 3? Okay, well that's not the question right now anyway. So, okay. Is 114 divisible by 4? What's the test for this one?
The last 2 digits are divisible by 4.
The last 2 digits. Well, what are the last 2 digits in this?
1 and 4.
1 and 4, so 14. Is 14 divisible by 4? Can we take 4 into 14 Or in other words, is 14 a multiple of 4? No, we can't get it, so we are going to say 14 divided by 4 is not, so we would, in fact, does anybody know what that would equal? What would be 14 divided by 4? Wait,
4 with a remainder of something.
not 4 with a remainder of something, it would be a, go ahead.
3 with a remainder of something.
Okay, it would be a 3 remainder 2. That's what it would be. 3 times 4 is 12. That would have a remainder. We cannot have a remainder, so the answer is no. Is 14 divisible by 4? The last 2 digits of the number. Okay. By the way, would 114 be divisible by 3? What do you think? 114 is it divisible by 3? 1 plus 1 plus 4. 1 plus 1 plus 4 is 6. Is 6 divisible by 3? Then 114 is divisible by 3. Okay, is 234 divisible by 9? What's the test we run it through?
Some of the digits.
Sum of the digits, add the digits. So 2 plus 3 plus 4. 2 plus 3 is 5. 5 plus 4 is 9. Is 9 divisible by itself?
Yes.
Yes. What do we get? 1. No remainder. So the answer is 234 divisible by 9?
Yes.
Yes. 234 is a multiple of 9. If we kept going with the 9s, 234 would be in the list. Okay, so now we're going to go to that other sheet that you did don't go to the back side of this one yet. We're not going to the back side. We're going to this right here. Okay, so our other sheet. Okay, now we're going to do some more practicing of these divisibility rules. So keep those divisibility rules in front of you. Use algebra to identify the different divisibility rules. The variable n, let's underline this, variable n represents any integer. It says circle the numbers that apply, show your work. Okay, so we have this list of numbers. Oh, that looks like that list that we had something to do with yesterday. Okay, so which numbers work for n over 2 and have no remainder? What are they actually saying here? N over 2, what's that mean? Sylvia? N divided by 2. So in other words, what numbers can you divide by 2? What numbers can you divide by 2? Okay, so what is 10 over 2? Is that a nice number? What is it? 5, okay. So 10 over 2 equals 5. So we're going to circle that one. How do you, and does it pass the test for being divisible by 2? What's the test for divisibility by 2? The last digit is divisible by 2. Can you take 2 into 0? You actually can. 0 times. Okay, how about 11? It ends in a 1. Can you divide 1 by 2 and get a nice number? No, so that one's not going to do it. We'll cross that one out. How about 12? Because 12 divided by 2 is 6. Or in other words, the last digit of 12 is 2. 2 can be divided by 2 and you get 1, right? Okay, so let's circle 12. Tell me something right now. What is n over 2 really representing then? The even numbers, isn't it? Because all even numbers are divisible by 2. So what are we going to circle? What's the rest of them we're going to circle? 14, 16, 18, 20, and 22. Okay. So we showed work for the first 2, and they were both even numbers. And now we're going to say, you know what? Because, so let's just put all even numbers. And This is the divisibility rule. So in other words, when they say this, they're talking about this, n over 2. What is this the divisibility rule for? 2. This is the divisibility rule written algebraically for 2. This is the algebraic, let's write that behind it. This is the algebraic way to express dividing by 2. Let's leave that off. When you have the divisibility rule for 2, it says take your number, divide it by 2. Take the last digit, divide it by 2. And if it's an even number, we decided, you know what, it has to be divisible by 2, doesn't it? Okay, what is this next one? It says, which numbers work for n divided by 3, n over 3, n divided by 3, and n divided by 2, and have no remainders. What is this the divisibility rule for? Has to be divisible by 3, and it has to be divisible by 2. Danny? This is the divisibility rule for 6. Let's go put that in here right now. Let's write that. This is the divisibility rule for 6. So let's go refer to what are the rules. What's the divisibility rule for being able to divide by 6? What's the rule for that one? The number is divisible by both 2 and 3. Can we eliminate some of those numbers that we know right away cannot pass both tests? Are there any of those numbers we can get out of there right away because they're not going to pass both parts of the rules? They can't both be divisible by 2 and by 3. We already know they're going to fail one of those tests. I'm waiting on him. Any of those numbers we can go and cross out because there's no way they're going to pass one of those tests. Sammy? 115. Why 115?
It's
It's not divisible by 2 or 3. Okay. And how do you know it's not divisible by 2, Sammy? Why can't you divide 115 by 2? Overall class. Why can't we divide 115 by 2? Because it's not an even number. Danny? Okay, so Sammy says it's not divisible by 3 either, and Danny says, no, I think 115 is divisible by 3. So what do we do for the divisibility rule for 3? Do we just look at the last 2 digits?
Yes.
No. What do we do? The sum of the digits, we add them all up. 1 plus 1 is? 2 plus 5 more is? 7. Is 7 divisible by 3? No, I guess Sammy's right. 115 isn't divisible by 3 either, is it? Okay, so, but first of all, we're going to just go through this list and we're going to say n divided by 2. Remember, we just said that has to be even numbers. Is 111 even?
No.
How about 113?
No.
Can we cross? Oh, we already decided we can cross out 115, right? How about 117?
No.
How about 119? How about 121? Oh, well, we've eliminated some of our list, right? Okay, so now we have to check out all these evens and see which of those evens is divisible by 3 because we already know they're divisible by 2. So what's 1 plus 1 plus 0? What's that equal? 2, okay. Is 2 divisible by 3? Is it a nice number? Can you take 3 out of 2? No, not nicely, okay. How about 112? 1 plus 1 plus 2. What's that equal? 4. Is 4 divisible by 3? No. So we just crossed out a couple more numbers, didn't we? Are there going to be any? Okay, how about 114? Oh, 114 we already did, didn't we? Remember I was asking you,
1 plus 4 is 6, and is 6 divisible by 3? Yes, it equals 2. So we get to circle a number finally. How about 100, we could be using these lines on here, I don't know why I'm doing it underneath. 1 plus 6 equals 8, is 8 divisible by 3? Or in other words, is 8 a multiple of 3? No, cross that one out. Okay, you finished the last 3. And if you need to move down to these other lines, you can, but ooh, I'm missing what I'm doing, my notes are. Okay. What'd you discover about 118? Yes or no? No? Okay, because 1 plus 1 plus 8 is 10. 10 is not a multiple of 3, is it? Okay, so we get to cross that one out. How about 120? 1 plus 2 plus 0 equals 3, and 3 divided by 3 equals 1. That one works. How about 122? Did that one work? Okay, why? 1 plus 2 plus 2 again is 5. 1 plus 2 plus 2 is 5. So we say, you know what, that one doesn't get to count either. How many numbers do we have that are divisible by 6? 2 numbers. 114 and 120 are divisible by 6. Okay, anybody remember what our first trick was? If it has to be divisible by 2, what did we decide we could do? What numbers can we cross out when it has to be divisible by 2? All the odd numbers. All the numbers that end in an odd digit. All the odd numbers get to be crossed out when it has to be divisible by 2. So get rid of those first, and then do the evens so that you can then run the evens through the divisibility by 3 test. Okay? Okay, let's go on to our last one on this page here. We have which numbers work for n over 5 and have no remainder. So, what's this the divisibility rule for? 5. This is the divisibility rule for 5. N over 5 is the algebraic rule for saying what numbers can be divided by 5. Okay, what was our rule for that again?
The number ends with 5 or 0.
It has to end in 5 or 0. So, has to end in 5 or 0. Let's put that on our first line. Has to end in 5 or 0. Because that's going to help us, first of all, I like to cross out first and then circle what's left and decide, did I miss any when I was crossing out? So, which is the first one I can cross out? 511. Okay, you go through the list and cross out all the ones that can be crossed out. Circle what you have left. Only all divisibility rules are that easy. Did you get the same 3 I did? Or do you have some more? Is that it? So we can say 510, 515, and 520 from our list are the ones that work for n divided by 5. In other words, if we would actually put them in for n, we could divide by 5 and have what? No remainders, okay? So anybody have questions on the divisibility rules? This is how we learn not to say, I don't know. Some of these divisibility rules are very handy to use, plus some of them are really easy to use. Some of them are a little bit trickier. If you want to show your genius off, ask your parents, come up with a number that's divisible by 9, and say to them, I'm going to give you 5 seconds to tell me if this number is divisible by 9. And then you have them give you a number and show them up, okay? You can do it. Okay, let's go to the other side of this one, We're going to do just the first 2, and there's a work page. Flip over the other page to the back side. That's going to be our work page. So we're going to solve some percent of increase problems here, but we're not solving today for what is the percent of increase. We have to find some other missing information, okay? So we have this crazy car wash that's giving us a whole lot of information. We're going to decide what can we cross out, what do we really need to help us be able to do this. So Craze, it's not crazy, it's Craze. Craze Car Wash cleans between 50 and 70 cars per day. They charge $10. They charge $10 for a wash and $12 to clean the inside of the car. Regular customers get a free car wash every 20 washes. Wow, that's a lot of information. On Wednesday, Craze Car Wash cleaned 60 cars. On Thursday, they cleaned 20% more cars than they did on Wednesday. How many cars, let's circle that, how many cars did they clean on Thursday? Okay, give me some information from all of that, you know what, it does not matter one bit to answering that question. Ikea, what's one thing we can cross out?
They charge $10 for the wash.
Yeah, that's nice information to have if you're gonna, decide if you're gonna get your car washed or not, but it has nothing to do with answering the question, how many cars did they clean on Thursday? Ken? The Craze Car Wash cleaned 60 cars on Wednesday. Do you think it's gonna be important that to figure out how many they cleaned on Thursday? It says they cleaned 20% more than on Wednesday. Won't we need that? We're gonna need that, aren't we? Yeah, so that's something we better underline actually. So on Wednesday, Craze Car Wash cleaned 60 cars. We do need that one. Okay, is there anything else that we don't need or do need? You can tell, give either or. Wait,
I'm gonna say they clean 20% more cars.
okay, are we getting rid of that or we need that?
I need that.
We need that. So on Thursday, they cleaned 20% more cars than on Wednesday. Okay, how about anything else that can be crossed out or needed? Tyler?
Craze Car Wash clean between 50 and 70 cars per day.
Yeah, in reality, that's not gonna help us solve the problem. It's nice to know, because it kind of sounds like, we should probably get an answer between 50 and 70, but other than that, it's not gonna be used for our problem. Anything else? I see another number there. Do we need it? Sam?
Regular customers getting a free car wash every 20 washes.
Okay, does that matter in the fact that we're gonna solve for how many cars they cleaned on Thursday? No, get rid of it. Every 20 washes, we don't care, except that we're gonna be a customer there. Right now, we're trying to solve how many cars did they clean on Thursday. So let's go to our work page and let's set up our problem. Now, did I write this on there? No, I didn't. Okay, so let's put this so we have it on this page. Anybody remember what the model looks like that we sub into? The model? What goes in the first ratio? What goes in the second ratio? Anybody remember the model? Harley? Amount of change. So let's call it AMT of change. Everybody fill that in first before we talk about any more parts. How much does it change by goes upstairs in the first ratio? What's downstairs in that ratio? IKEA? The original amount, starting amount, original, whichever way you want to say it, starting or original amount. Okay. What goes upstairs in the other ratio? What's upstairs in the other ratio? Harley?
Percentage change.
Percent of change, okay? Percent of change. How much, what was the percentage it changed by? And what's downstairs in that ratio? Class? 100. Every percent model we've used has a 100 there. Every one of them. Okay, so now that's our model, so that when we're doing our work on the work page, we're gonna use that information to help us set it up. So, anybody think we know how much it changed by? Did any of that information we have underlined tell us how much it changed by? The number, amount of change, not percent? No, we don't have that, do we? Do we know how much it started at? What did it start at? What was it on Wednesday? 60, that's the starting amount, okay? Do we know the percent of change? What is it? 20%, so we'll be using a 20 up on that one. We don't use the percent sign, we can just put a 20 there. And the 100 is 100, isn't it? Okay, so on our work page, let's get that ratio set up. So we are going to have, we said, we don't know what the amount of change is, so we're going to call that X. On Wednesday, the starting amount was 60. That's how many they washed on 60, or on Wednesday. We said it changed by 20%, so we put a 20 upstairs, and we put our 100 down. So right now, what are we finding? Okay, we amount of change. Is that going to give us how many they washed on Thursday? No, we're going to have to do what? It says first find the amount of change and then add that to what they watched on Wednesday. So is this friendly? Okay, what do you want me to do, vertical or horizontal? Sylvia? Vertical. Oh, I'm supposed to read your sign language here. Okay, vertical, she says. Okay, so what do we have to do to 100 to get 20? Caden? Divided by 5. So we'll come over here and we'll do the same thing. So we're going to have 60 divided by 5 equals X. 60 divided by 5. Anybody got it for us? 60 divided by 5? Danny? 12. Okay. X equals 12. That's 12 what? Okay, that's 12 cars. 12 cars on Thursday? 12 cars less than Wednesday? 12 cars more than Wednesday? Wait. 12 cars more. Let's put the word more behind that even. We have not found out how many they washed on Thursday yet. We have not found that out yet. We just know that now that tells us they washed 12 more cars on Thursday than they did on Wednesday. So what do we have to do now? 60 plus 12 equals 72 cars on what? Thursday. They washed 72 cars on Thursday. So notice that number that they wash between 50 and 70 cars a day. Does that mean our answer is wrong? No. Remember it said we
We were just looking for the things that we needed to answer the question. We answered the question, that's probably like an average, that's just saying, oh, we usually wash somewhere between 50 and 70 cars. I guess this was a good day or a bad day? This was a good day, wasn't it? Okay. Okay, let's go back to the worksheet and look at problem number 2. We have to move a little faster on this one. Okay. So we have people who fly a lot get bonus miles that they can use to get free tickets and other kinds of upgrades. Mara Johnson flies a lot for business. She usually flies back and forth between Chicago and Dallas for business. Each trip is about 1,600 miles. Last year, Mara flew 50,000 miles for business. This year, she expects to increase her business travel by 20%. How many miles does she expect to fly? You know what? It doesn't really matter where she usually flies, does it? It does not matter that each trip is about 1,600 miles. We don't really care. We want to know how many more miles she expects to fly this year because she's going to increase her travel. So we need that last year she flew 50,000 miles. We need to show that this year she's going to increase her business travel by 20%. How many miles does she expect to fly? Oh, by the way, we can come up here and answer this question 72. Okay? Okay, so let's go to our work page and set this up. Do we know the amount of change? No, we're going to need, that's what we're looking for. How many more miles is she going to fly this year? How many did she fly last year? 50,000, that's our starting amount. How much is she going to increase her travel by? 20%, so 20 over 100. Okay. Friendly, horizontally, vertically, both ways it actually is, but probably more friendly vertically. What do we have to do to 100 to get 20 again, class? Divide by 5. So we have 50,000 divided by 5 equals X. Harley? What is it? 10,000. X equals 10,000. 5 goes into itself once, and then you attach 4 zeros to it. So that's 10,000 what? Miles and more miles, right? She's going to fly 10,000 miles more this year than she did last year. So what do we have to do yet? Add this to, add this to, add this to, thank you, 50,000. Add those guys together. 50 plus 10 is? 60. So 60,000 miles this year. 60,000 miles this year by increasing her business travel 20%. Go back to the other page where the problem was on. I have a sentence for you there for you to fill in the blank. So we're going to fill in the blank right here. 60,000 miles. Okay? Okay, you do need loosely. I guess that's pretty much a given every day, isn't it?